So this section is called multiple angle and product to sum formulas, and all it is just a bunch of trig formulas, and that would be a good idea to at least familiarize yourself with. There's a couple that are much more used than others, and I'll kind of say that as I go. In this video, I'm only going to talk about the first two groups of formulas, and that are the double angle formulas and the power reducing formulas, and then in the upcoming videos I'll talk about more of them, but I'll just try to keep this one straightforward. Basically you are just doing problems to help you remember these formulas, okay? So they're not very hard to deal with in general. It's just a bunch of substitution. You start playing around with them a little bit more in some of the sections, but I'm just going to go through these first couple. Everything is in play, so they give us this right triangle, so we're being asked to find all of these trig functions, so that does mean we need to find the hypotenuse. Hopefully you see this as a 3, 4, 5 triangle, and so this would be this side length, the hypotenuse would be 5, and if you don't, then you can just do Pythagorean's theorem to find it, but that's a 5, and so I'm just going to go through the evens here. Nothing is different. Just because we add some formulas doesn't mean things change. Tangent of theta, right? We're still thinking SOHCAHTOA, that still applies. So then that's opposite over adjacent. So that's all that one is. Right? The sine of 2 theta, right? You see over in the double angle formulas over here that the sine of 2 u is 2 times sine of u cosine of u. So, we're just going to substitute that in first. So, sine of 2u, or 2 theta, equals 2 times the sine of theta times the cosine of theta. And so that's 2, right, sine, SOHCAHTOA, opposite over hypotenuse, so 2 times 3 over 5. And cosine is 4 over 5. And then we're just multiplying these out. And we get 24 over 5. 24 over 25. All right. Excuse me. The way I'm going to do 6 and 8 are to find the reciprocal of secant and cotangent, and then take the reciprocal of that answer. So, the reciprocal of secant is cosine. So the way I'm going to do number 6, because you notice they don't give us any of those formulas, the way I'm going to do number 6 is say, okay, the cosine of 2 theta, and they work it all out, and you're welcome to use any of these versions. I'm just going to go down to the bottom one. And so that's the same as 1 minus 2 sine squared of theta. So then 1 minus 2, sine is still 3 over 5 squared. So we'll simplify that. I'm going to change 1 into 25 over 25. Minus, right, 3 times 3 is 9, so times 2 is 18 over 25. And so then that would be 7 over 25. But, we're not asked to find cosine of 2 theta, we're asked to find secant of 2 theta. So then secant of 2 theta in this case is 25 over 7. Alright, so we'll do number 8. Try to keep it all on the screen here. So again, we're being asked to find cotangent of 2 theta. I'm going to use tangent first, and then just take the reciprocal of that. So tangent of 2 theta is the same as 2 times tangent of theta over 1 minus tangent squared of theta. And so then we're just going to manipulate our triangle some more. So tangent is 3 over 4. We found that on number 2. So then 2 times 3 over 4. 1 minus, right, 3 over 4 squared is 9 over 16. So 2 times 3 over 4 is 3 over 2. And then, right, 1 is 16 over 16. So 1 minus 9 over 16 is 7 over 16. This is your keep, change, flip. So that gives us 24 over 7. And again, we're not asked to find tangent. We are asked to find cotangent. So I'm just going to take the reciprocal of that. So then cotangent of 2 theta in this case is 7 over 24. Okay, so really not a whole bunch going on. Just trying to remember these formulas, and so you're just going to have a lot of that. Okay, so we're going to solve some trig equations. I just picked 2 out of this section to do. They are telling us that we're going from 0 to 2 pi, 2 pi not being included, and so we don't have to worry about adding the extra answer. We're just going to find it on 1 unit circle basically. All the rules on solving these are the same. Ideally we get it down into one of the trig functions. This one's set up pretty straightforward because we have an obvious one that we're going to play with on this first one. So sine of 2x, and we're going to substitute in, right, what sine of 2x is, and so that's 2 times sine of x cosine of x. Pretty good hint is that it's already set equal to 0, and the other thing is we have 2 terms now with a cosine, so that makes me want to try factoring out. So I'm going to take out a cosine of x. We're left with 2 sine of x plus 1 equals 0. And now that we have 2 factors that equal 0, we can set each of those equal to 0. And remember the way these work, you're saying to yourself, the cosine of what angle gives you 0? Remember that cosine is the x values, and so we're talking about, and if you don't remember these, check out your unit circle, but cosine of pi over 2 would produce a 0, and cosine of 3 pi over 2 would be 0. Okay, remember cosine is your x values on the unit circle. We're going to solve for sine of x here. Okay, and then the same process, right? What angle, the sine of what angle gives you negative 1/2. So remember that sine is your y values on the unit circle. So the y values have to be, the y values are negative down in the 3rd and 4th quadrant. And so again, if you don't remember these, check out your unit circle. So down at 7 pi over 6 and 11 pi over 6. So not much different, right? You just got another formula that you can play around with. So here's another one I picked, and I picked it because of the tangent. And this one gets a little bit involved, but this is a good one to go through. So again, the weird part is that 2x, and so we'd like to get it just to an x, like tangent of x. So I am going to just substitute the tangent 2x formula in. So then that means tangent of 2x is now 2 times tangent of x over 1 minus tangent squared of x. Okay, and you know, this still looks pretty complicated, and all we can do is just try some things out and see what happens. I'm going to add the 2 cosine of x to the other side. So again, while I'm doing this, you know, don't get frustrated on these. It just takes practice and experience to know the probable quickest option. That doesn't mean you're always going to get it. I'm going to multiply both sides by 1 minus tangent squared. Now I'm going to divide both sides by 2. And then distribute the cosine. And again, you can't be afraid to try this out. You're not always going to get this right on the first try. I'll write like this. And that's called doing math. I mean, you know, you got to try things out and see what happens. You know, this looks a little obnoxious at this point, but do remember that tangent is just sine over cosine. So I'm going to rewrite my tangents as sine over cosine. And so tangent squared is sine squared over cosine squared. So I am going to save a little room and write this last term as just this, right? Because one of those cosines would cancel. Now, just like any other equation, I would rather not deal with fractions if I don't have to. Luckily, we don't have to right now. So I'm going to multiply this whole thing by cosine of x. So then it's going to be sine of x equals cosine squared of x minus sine squared of x. And now we're really close. You know, our whole goal is to get these equations in terms of one trig function, if at all possible. So I'm going to use Pythagorean identity for the cosine squared of x. And substitute in 1 minus sine squared of x there. Now we have this whole equation in terms of sine, which is very nice. And, you know, especially with these squared terms, I'm going to think, you know, this is probably going to be something that we can factor. So I'm going to get everything to the left-hand side. Go ahead and factor it. You know, just be careful on your signs. You know, quick check of it. Right, there's 2 sine squared. There's a positive 2 sine minus 1 sine is positive 1 sine, and then our negative 1. And we can set both of these equal to 0 now. So then we have 2 sine x minus 1 equals 0. And sine of x plus 1 equals 0. So then sine of x equals 1/2. And sine of x equals negative 1. and we're going through that same process as we did on the last one, right? What sine of what value, sine of what angle gives you 1/2? So positive 1/2 this time as opposed to the last problem, which was negative. So we know we're in the first and second quadrant, and that means pi over 6 and 5 pi over 6. Again, check out the unit circle if you don't remember those. Then sine of x equals -1. As far as I know, or as far as I can think, that only happens in one spot because we're talking about the y values, and that would be down at 3 pi over 2. The back of the book also has pi over 2. I'm not sure really where that came from because sine of pi over 2 is +1. And, you know, if you substitute in, at least in our pre-factored equation, that wouldn't work out as being +1. So I'm going to say this is the answer. I don't know. Maybe I'm missing something, but those are the three answers that I got. All right, so I did want to do one more from this section, just so you understand what they're asking you to do. They're saying use the double angle formula here, and we don't have a double angle formula as right now. But if I do take out a 2 here, then we would have 2 sine x cosine x plus 1, and this part is the right-hand side of the sine of 2x formula. So then I'm going to substitute that in, kind of going in reverse than what we did on those previous ones. So now it's 2 times sine of 2x plus 1. And then, of course, you can distribute that back if you'd like. It's not necessary, I suppose. But that's what they're asking you to do on that little 19 to 22 section. Okay, so for the last problem I'm going to do with the double angle formulas is just this first one in the last section here of the double angle formula stuff, 23 to 28. They're asking for the exact values of sine of 2u, cosine of 2u, and tangent of 2u. And they give us this statement as well as this statement. Okay? And anytime you're given a ratio for your trig function, then you should think of drawing yourself a triangle so that you can find all the rest. And this part of the statement is just telling you which quadrant that you're in, you know, because we have to worry about our negatives and positives. So we're, right here's, if you're thinking of the unit circle, right, here's pi over 2 and here's pi, so that means we're in the second quadrant on this. And there's u. So then remember that cosine is adjacent over hypotenuse. This is going to be our negative, and our hypotenuse is always positive. And then we have to do Pythagorean's theorem to find the missing side, because we're going to need to deal with that with the sines, and also the tangent. So then we would have 9 equals 4 plus b squared. So b squared would equal 5, and then b would equal positive or negative radical 5. In this case, it is going to be the positive because we're in second quadrant right above the x-axis. So now there's your triangle, and now really we're just going to mess around with these double angle formulas a little bit more. I'll try to go a little quickly through these. Right, sine of 2u is equal to 2 sine of u cosine of u. So that's 2 times sine, right? Opposite over hypotenuse. So 2 times square root of 5 over 3. cosine we already were given as negative 2 over 3, or use the triangle. And when you multiply all that out, you would get negative 4 radical 5 over 9. Okay, so then cosine of 2u, going through the same process, right? Cosine of 2u is 1 minus sine squared u. So that's 1 minus 2 sine squared u. So then that is 1 minus 2, right? Sine again is radical 5 over 3 squared this time. And so then we would get 1 minus 10 over 9 when you finish all that out, and so then you would get negative 1/9. And finally, the tangent of 2u is the same as 2 tangent of u over 1 minus tangent squared. Alright, so then tangent, let's go back and check real quick. Right, tangent is going to be radical 5 over negative 2. So 2 times radical 5 over negative 2 over 1 minus 5 over negative 2 squared. So that gives us negative radical 5 up at the top. And then 4 minus 4 minus 5 over 4. And so then the tangent of 2u is going to be 4 radical 5. Okay, so for this last problem, we're going to do one of the power reducing formulas. I'm only going to do one. As you can tell by the allotment of problems, this one is not as big a deal as the double angle formula one. So we're just going to do one of these. You know, it's just another formula to memorize or to work with anyway. At least be familiar with these, so you're not shocked when you see them again. You know, we're only given sine squareds. We're asked to simplify to the fourth, and they are asking us to rewrite the expression in terms of the first power of the cosine, which is nice because all of these have cosines in them. So I'm just going to do some substitutions here, and we can rewrite sine to the fourth as sine squared. So that means we can now write it as 1 minus cosine 2u over 2 squared. And then now it's just about simplifying. Right, this is 1 cosine of 2u times 1 minus cosine of 2u. Over 4. So when we FOIL all that out, we get 1 minus 2 cosine of 2u plus cosine squared of 2u over 4. I'm going to take the 1/4 out to make this a little bit easier to look at, because we're not quite done, because again the directions are asking us directions are asking us to rewrite it as the first power of cosine. So now we have this cosine squared of 2u that we're going to have to deal with. So, right, we're going to use this formula. Now, we are going to have to pay attention because the formula gives us 1u, but we have 2u, okay? So the formula tells us to multiply whatever this angle is by 2, okay? So just, that's where this 4 is going to come up. This is where I'm talking about. So we have 1/4, 1 minus 2 cosine of 2u plus, now we're going to write cosine squared of 2u as 1 plus cosine of 4u, right? Because whatever's inside there is multiplied by 2, and what's inside of ours is 2u, so 2u times 2 is 4u. And that's pretty good. In the back of the book, they factor out this 1/2 here. I don't know how necessary that is, but you know, it is necessary if you're not sure if you're doing it right. So if we take out a 1/2, then that becomes 2. This becomes 4. And now we have 1 plus cosine of 4u, and I guess we can combine another term, so I guess it is kind of nice. And, you know, it is really easy to check. It's weird to do that kind of factoring at first, but, you know, if we distributed 1/4 to 1, we'd get 1/4. So if we distribute 1/8 to 2, we better still get 1/4, and we do. Okay, so I know that's a little bit weird at first to think about, but I imagine you're pretty tough, unless you've softened up since the last time I've seen you. And there you have it. So please ask if you're not sure, and I have another couple of videos coming. And obviously, you know, I substituted in u there on accident. The answer is in terms of x. So I guess I'll rewrite that. Not the biggest deal in the world, but right, we start with x, so we should have stuck with x. So really, I guess this is the answer.